Joe Trabulski, VP of Sales and Marketing here at Hitachi Comarch. In our last few videos, we provided an overview of our CDS powered by Titan Live software-based encoding solution and how it supports multiple workflows for ATSC 1.0, 3.0, and OTT, as well as dedicated feeds to MVPDs. One of the key benefits of software-based encoding is that it simultaneously supports multiple output formats with different codecs, including MPEG-2, H.264, HLS, and HEVC. For an ATSC 3.0 OTA broadcast, we configure an HEVC output of the encoding system with the integral dash packager. This encoded signal feeds what we call the ATSC 3.0 stack, which provides additional signal grooming and PLP configurations for next-gen TV services. The ATSC 3.0 stack consists of a route server and a broadcast gateway that ultimately feeds your ATSC 3.0 exciter and transmitter. Over the past several years, CDS has worked with all the primary vendors that supply ATSC 3.0 stack equipment, and for this video, we will be demonstrating the stack from Enensys Technologies. Now let's head to the CDS lab. So here we are in the CDS lab, and what we're going to show you is the Smartgate and Mediacast products from Enensys. These are the products that immediately follow the ATSC 3 encoding system and precede the exciter in the transmitter. So just a quick recap of encoding for this demo. We're looking at the Titan Live. Here we have two video streams, CDS1 and CDS2. Both are in HEVC dash using these IP addresses, and that's what's feeding the first device called Mediacast. So Mediacast is responsible for processing three main things. First of all, live AV content using either dash route or MPU and MMTP. Again, in our case, we're using dash, and this will add the route to it. It's also responsible for processing NRT via route, and that would include ESG, advanced emergency alerts, and interactive applications, and also for adding the service signaling, the SLT or service list table, the SLS, or the service layer signaling, either via route or MMTP protocols, and also the LLS, the low layer signaling, including the BSID. So all that stuff happens here in Mediacast. The first screen we're looking at is the dashboard. So you can see here are your services down here, linear AV1, linear AV2. So again, these are the two feeds coming from the encoder. We're also doing electronic service guide here, and Steve is our nickname for the non-real-time app-based file that we're delivering. At this point, we're not sending anything, but it's set up to do that. So graph shows you the amount of bandwidth per stream. So you can click on any of these and see the specifics about the service, what route protocol is being used, major minor channel numbers, etc. So this is the dashboard, gives you an idea of what's happening within the route generator. Here we have the signaling tab, so we are on dashboard. We have the signaling tab. Again, this is where the LLS is generated along with the service list table and the advanced emergency alerts, etc. And then we have the services table. This shows all the services that are being delivered and how you add them. There is an alarms page. At this point, the alarms and the logs are empty, so we're going to skip that. And then this is the setup for the unit, where you can get in and do, administrative kinds of setup, date and time, user management, networks, what licenses are installed on this product, etc. About also shows you user manuals and things like that. So that's the overview of the Mediacast and what's being sent to the next processing, which is the Smartgate. So the Smartgate is the broadcast gateway. This is really the brains of an ATSC 3.0 signal. This is where the system is set up to determine what modulation, what coding, the number of PLPs, how the PLPs are mapped, whether you're using layer division multiplexing, SFN, all that. That's all set up here. So basically, there are much like Mediacast, there are menus up here: dashboard, ATSC 3 signaling, PLP mapping. So the dashboard is the overview. Here you can see we have 2 PLPs set up. The total throughput for this ATSC 3 setup is 19.8. The amount of data going to the transmitter via the STLTP, because there's overhead for STLTP, is a little bit higher at 20.7, 20.75, somewhere in there. Again, 2 PLPs. You can see one is set for 64 QAM with this code rate and this FEC. PLP number 1 set up for a higher modulation, 256 QAM, different code rates, etc. So overview. If you go to the next tab, ATSC 3, this shows how the system's been set up in terms of PLPs. So here again we have 2 PLPs. If we wanted to add a third, just click the plus button, and in each of these you can set up all the different parameters per PLP. So the constellation, the code rate, the inner and outer FEC, whether it's LDM or not, etc. All that stuff set up in here. And you can go back and look at what each of the PLPs are already set up. So this is PLP 0. This matches the dashboard with 64 QAM, 13/15 code rate, 64K LDPC inner code, etc. And again, PLP, basically the same, except we're using 256 on that one. I'm going to click cancel because I don't want to add another PLP. In the signaling, so this device will look to see what's coming in on the network. Because this is the CDS lab, we actually have more than one ATSC 3 encoding system. So this is one source, this is a second source. So this is the source that's being used. You can see all of the items here, your 2 video channels, your ESG, and our Steve and RT application has been added to the output here. In the PLP mapping, again, you have all your services over here, your 2 audio video, you got WWLP DT and CDS test, and how those are mapped. So PLP 0 has the LLS, it has this video, it has ESG, and it has our little Steve NRT system. And then in PLP number 1, we have CDS test, so that's how it's all mapped in there. Final tab is STL output, or the STLTP. And again, here you can see all of the different parameters that are set up within the Smartgate, which will be feeding the exact exciter in our transmitter. Same in this program, you have the settings where you can get in and do date and time, user management, network, etc. And also you have alarms. This one does have some alarms, so you can see, general alarms, processing alarms, and then there's also an alarms log. So that's the summary of the 3 pieces of software used to generate ATSC 3. Again, Titan Live generating HEVC dash, Mediacast doing the signaling and route, and then Smartgate, which is doing all of the PLP setup and creation of the STLTP. In summary, the ATSC 3.0 stack provides broadcasters with ATSC 3.0 signaling table generation, including the SLT and SLS, encapsulation of linear and NRT content, ESG and EAS into MMTP or route protocols, the ability to configure QoS with multiple PLPs and SFN definition for the STLTP output, a software-based solution that runs on VMware or on a public or private cloud infrastructure, and built-in HTML web GUI with no need for an external supervisory system. For more information or a quote, simply contact us at sales@comarktv.com. Think Hitachi Comark and CDS for all your RF test equipment, ATSC encoding, and next-gen TV needs. Don't forget to like, share, and subscribe to the Comark TV YouTube channel for future videos. Thanks for watching.